discuss section number 1.5, revisiting rational numbers and their decimal expansions. So basically we are going to see what rational numbers mean, and we are going to see the different types of decimal expansions that rational numbers can have. In previous classes, you studied that rational numbers have either a terminating decimal expansion or a non-terminating repeating decimal expansion. So you might know that rational numbers have a terminating decimal expansion, which means that when you divide and when you try to express them in the form of decimals, the decimal expansion stops at a certain point, and non-terminating means that it keeps going on and on and on. So today we are going to revisit these definitions and learn about these in detail. So we are going to see what this actually means. We are going to take a look at some examples also, so that you're able to clarify all your doubts regarding these definitions. So let's take a look at some definitions. Terminating decimal expansion, a decimal expansion that ends. It's a decimal with a finite numbers of digit. So basically a terminating decimal expansion of a rational number we are discussing here would mean that a decimal expansion that ends after a point. So it has finite numbers of digit, and you can basically that it has stopped and has ended at a point. You can know about it. So let's take a look at some examples. 0.5, 2.456, 123.456, etc. are all examples of terminating decimals. So here you can see that the decimal expansion is finite with a limited number of digits. So this is what terminating decimal expansion means. Moving on, non-terminating decimal expansion. Decimal expansion which keeps on continuing after decimal point. So basically when the decimal expansion keeps on going even after the decimal point and it doesn't stop at a fixed number of digits, that is called non-terminating. So let's take a look at some examples. Pi is equal to 3.14159 and so on. You can see that the decimal expansion of pi keeps on going on, and root 2 also is equal to 1.414 and dot dot dot. So basically usually irrational numbers have non-terminating decimal expansions. So here you can see that these two decimal expansions don't seem to end. They keep on continuing after the decimal point. Moving on. So today we are also going to discuss types of non-terminating decimal expansions. So you might be already aware about the fact that non-terminating decimal expansions are also of two types. So we are going to take a look at the types here, because in the future you might be posed with some questions which need these concepts and you might be not aware of it. So let's take a look. Non-terminating, non-recurring. So this is a type of non-terminating decimal expansion. Let's see what it means. The numbers will continue forever and will never form repeatable sequences. So basically the definition is that the numbers will continue forever. What this means is that the decimal expansion would keep on continuing and there will be never a pattern in the numbers. The numbers are going to be non-recurring, that means not repeating. So there will also be a different sequence and different numbers, so you will not be able to have a clear pattern. So let's get it more clear by taking a look at an example. Example 2.23606. So if you take a look at the decimal expansion of this number, it keeps on going on and on, but it has no pattern. It will become more clear when we will see the other definition, because that would be a better example for you, so that then you will be able to understand the real meaning. The second type is non-terminating and recurring. So let's see what this term means actually. The numbers will continue forever, but one or more numbers will repeat after the decimal point in a predictable pattern. So in this type of decimal expansion, it is still non-terminating, but it is recurring. Recurring means repeating basically. So the numbers will continue forever. Basically, the decimal expansion will keep on going, but one or more numbers will repeat after the decimal point in a predictable pattern. So you will be able to see a pattern in the decimal expansion. Let's take a look at an example. So this is a very basic example, 3.33333 and so on. So you can see that after the decimal point, the number 3 keeps on repeating, and this is a pattern. So this is a very basic example, but now you will be able to understand what I mean by repeatable sequences. So basically, this was just an introduction to these definitions, and we are going to discuss more things in the future. So I hope that I made these definitions clear today and you were able to understand what I was trying to communicate, and you also had fun watching this video. Thank you so much for watching.